Hey everyone, welcome back to the channel where we dive deep into the weirdest and most wonderful corners of science. Today, we're retackling a question that seems to break the laws of physics as we know them. Can hot water freeze faster than cold water? It sounds completely backwards, right? You'd think the colder water has a head start, so it should win the race to become ice every single time. But what if I told you that's not always the case? This baffling phenomenon is known as the Mpemba effect, and it's one of nature's most mind-bending puzzles. The story goes back to the 1960s when a Tanzanian schoolboy named Ernesto Mpemba was making ice cream. He noticed that his hot ice cream mixture froze much faster than his classmates' colder mix. Naturally, his teacher dismissed it, saying it was impossible. But Mpemba was persistent, and his observation eventually sparked decades of scientific debate. So, what's actually going on here? How can something hotter freeze before something colder? Well, scientists have proposed several theories, but the fascinating part is there's still no single, universally accepted answer. One of the leading explanations is evaporation. When you have a container of hot water, it evaporates more quickly than cold water. As the water turns into vapor and escapes, the total mass of the water left in the container decreases. Less water means less mass to freeze, which could potentially speed up the overall process. Think of it like this. If you have to freeze a full bucket of water versus a half-empty one, the half-empty bucket will freeze faster. Evaporation essentially gives the hot water a shortcut by reducing its volume, but that's not the whole story. Another major factor is convection. Hot water isn't uniform in temperature. It's hotter at the top and cooler at the bottom. This temperature difference creates strong convection currents, with the warmer water rising and cooler water sinking. This constant circulation helps the water lose heat to the surrounding cold environment much more efficiently. In cold water, these currents are much weaker, so the heat transfer is slower. It's like the hot water has a built-in fan, actively cooling itself down, while the cold water is just sitting there, waiting more passively. Then there's the role of dissolved gases. Cold water can hold more dissolved gases like oxygen and carbon dioxide than hot water. When you heat water, these gases are driven out. Some scientists suggest that these dissolved gases can somehow interfere with the freezing process, perhaps by altering the water's freezing point or its ability to form ice crystals. So, by boiling the water first, you're essentially purifying it in a way that might make it easier to freeze. It's a complex interplay of factors, and what's wild is that the Mpemba effect doesn't always happen. It depends on the specific containers, the initial temperatures, and the surrounding environment. Even after all these years of research, the Mpemba effect remains a scientific enigma. It's a perfect example of how a simple observation can challenge our fundamental understanding of the world. It reminds us that there are still so many mysteries waiting to be uncovered, sometimes in the most everyday situations, like making a tray of ice cubes. What do you think is the main reason behind this bizarre phenomenon? Let me know your theories in the comments below. Thanks for watching, and if you enjoyed this journey into the strange world of science, don't forget to like, subscribe, and hit that notification bell so you don't miss our next video. See you next time.